Good afternoon, everybody. Today I am going to present a lecture on the topic stock oblique strip layout. So, let me tell you what is stock layout. Now, stock strip layout, it gives the position of the workpiece in the strip and their orientation with respect to one another. Means whether the workpiece is in vertical position or horizontal position, and even the direction, it has to be considered when we consider the stock strip layout. So, the factors which will influence the strip layout are economy of material, means the cost, which is the main factor, direction of the material, grain or fiber, that is whether it is vertical position or in longitudinal position, it really depends. Strip stock, that it is whether it is coiled stock or strip stock, direction of burr, that whether it is clockwise or anti-clockwise, what press we are using for this purpose, and what is the production, whether it is mass production or intermittent production. Then again the die cost, which is the major factor. Now, material economy is of most important point in the press work, that is the cost of the material. Now, blanking being the first operation, so raw material economy is affected by using the most economical strip layout, which can give the highest material utilizations. Mean we have to choose that strip layout which will give us the maximum material utilization, because if material utilization is maximum, obviously losses will be less and the cost will be low, ultimately profits will be high. Now, what do the experienced press tool designers they do? They draw at least 3 strip layouts, then compare their material utilizations before coming to the final design of the blank tool. Now, I will show you the figure which tells us the various shapes of the blanks. Now, as shown in figure 1. So, this is the figure 1. In this there are various designs of the layouts. So, we will study one by one. Now, first one is a rectangular blanks, they are normally blanked in a straight layout. So, if we are cutting the rectangular blanks, they are arranged in a straight layout, whereas L shaped, now L shaped blanks they can be produced economically on an angular layout. So, this is the diagram showing the first one is the rectangular layout and second one is the L shaped blanks, they are being arranged in a angular layout. Now, the small circular blanks, they are usually arranged in a staggered rows, means uneven rows, and the number of rows depending upon the blank size and press capacity, whereas blanked shaped like letters T, U and W, they can be produced economically by inverted layout, means one letter straight and other one inverted. This I can also show in the diagram. Now, this E part, it is the showing the inverted layouts, means one letter is straight and other one is the inverted one. Now, in inverted layout what happens is that the two blanks they can be shared simultaneously, or what happens that the strip can be turned down and fed again in a simple blanking die. Now, as shown in the figure, you can see that material utilization, it is maximum in rectangular type, it is 80.3%, which is very important factor to be considered. And now, in case of angular layout, you can see that utilization is 68.2%, and in the third layout, which is circular layout, you can see that it is utilization is 56.4%, and in inverted layouts it is again 69, 40, 68, 38. So, we can say that the maximum material utilization is in case of straight layouts. Straight layouts are the best one. Now, figure 2 shows 3 layouts for the component given and state the material utilization for the layouts. So, this is the figure 2 and the 3 layouts are being drawn for that single component, which is L shaped component. So, first one is the angular layout and second and third, these one are the straight layouts. or it is clear that straight layouts give more material utilization than the angular layouts. Now, when the blanks are shared from a flat sheet, the length, it should not be an integer multiple of the blanking pitch. That is, the length should be whole number. It should not be the integer multiple of the blanking pitch, because otherwise this will lead to the end wastage due to half partial cuts at the tail end of the strip. Because we have to consider this end wastage, this must be taken into account while computing the material utilization. So, as shown from the figure, you can see that the straight layout, it gives more material utilization as compared to the angular layout. In the case of angular, it is 50.8%, while in case of straight layout, it is 61.9% and 62.2%. Now, if a big roll of coil strip is used, then the material utilization, how to calculate material utilization? It can be calculated by dividing the area of 100 blanks with the area of the material required for producing those blanks. Means material utilization is equal to area of the strip before blanking divided by area of the blanks which are obtained from that strip. Now, the strip layout with maximum material saving, it may not be the best strip layout. We cannot say that the layout which gives the maximum material utilization is the best layout, as the die construction may become more complex in case of that straight layout. So, which will naturally overcome the savings which we have done due to the material economy. So, we cannot say that strip layout which gives maximum material utilization is the best one, because it can result in complex die structure whose cost is more than the material which we have saving. Now, another important consideration in the strip layout is the distance between the nearest points of the blanks, means distance between the two blanks and between the blanks and the edges of the strip, as shown in figure 3. So, this is the figure 3. Now, the distance between the two blanks, it is denoted by point B, which is called as the scrap bridge, and the distance between the blank and the nearest point is called as back scrap A or front scrap A. Now, to prevent the scrap from twisting or wedging, means bending between the punch and the die, now this distance, it must increase with the metal thickness. Now, the general rule of thumb is to keep this distance called web at least 1.5 times the material thickness, that is, it should be the 1.5 times the material thickness. Other factors such as strip thickness, hardness, type of operation, that is what operation we are going to perform, whether it is blanking or bending or notching or stripping, shape of the blank, etc., they may allow web to be thinner. Diagram that I have already shown, this is the nomenclature of the strip layout. Now, feet is given, feet, how much feet should be given, W is the width of the blank, L is the length of the whole strip, H is the height of the blank. Now, the distance between the blank and the edge of the strip, known as back scrap, I have already shown you in the diagram. It is determined by the equation A is equal to T plus 0.015 into H, where T is the thickness of the strip and H is the height of the blank. Now, the distance between the successive blanks and also the scrap bridge B is given in the table as shown. Now, if the material thickness, it is in mm, if it is 0.8 mm, then B scrap bridge value, it will also be 0.8 mm, and if it is the thickness is between 0.8 and 3.2, then V will be equal to thickness, and if thickness is over 3.2, then again B will be equal to 3.2. Now, in general, softer and thinner materials, they require large spacing. Now, the feed or advance, that is, or length of one piece of sheet needed to produce one blank, it is given by the formula S is equal to W plus B, where S is the feed or advance, W is the width of the strip and B is the back scrap. Now, the number of blanks which can be produced from one length of sheet, it can be found out with the formula given as n is equal to L minus B upon S, where L is the length of the blank and the scrap remaining at the end of one length of the strip, it is may be calculated as by the formula y is equal to L minus n into S plus B. All notations I have already told you. Now, the percentage utilization, it should not be less than 70% for economical working. Means for economical working, we can say that the material utilization should not be less than 70%. However, we can say that for complicated shapes, it can be even less than 70%. Now, next comes the direction of the material grain. It is very important that what direction is of material grain. Now, direction of material grain, it is considered if the cut blanks have to undergo any subsequent operation like bending or deep drawing. So, we have to consider the direction of the grains in case of bending or deep drawing. Now, if the sheet, when the sheet metal it is rolled in the mills, then grains they are elongated in the direction of strip length. Now, during subsequent bending, what happens is that to obtain maximum strength, the bent parts, from the bent parts, the bend should be made, it should be across the strip or at an angle of 90 degree to the direction of the fiber. Means if the fiber is, it is in longitudinal direction, then the bend should be in the horizontal direction. It should be 90 degree to the direction of the fiber. Now, another important consideration in the strip layout is whether the stock used is in the form of a strip or coiled. Now, in case of the coiled stock is used when production is high and the thinner metal sheets are used. When we are using thinner metal sheets and the stock, it needs to be passed through the die only once, means the strip it is being fed only once through the die. Now, second one is in the strip stock. In case of strip stock, it is used when production is low and the thicker metal is being used. We are using thicker sheet metal and the stock needs to be passed through the die more than once. So, this is the difference between the strip and coiled stock. Now, what happens during production planning? The strip layout, it has to be such that it allows the die to be designed within the press capacity. That is, the shear it has to be provided on the punch or die to limit the cutting force within the press capacity. Another factor in case of production planning is that the bed area of the press, it should be to the blank area of the strip. That ratio should have to be maintained, and the third factor is that the cutting forces of the die, they should be evenly balanced around the center line of the press ram, because if the forces are cutting forces, they are not evenly balanced, then it can lead to the breakage of the punch or anything can happen. Now, the following guidelines they may be followed when production is the main consideration. As when we are stressing on production, so the following are the guidelines. Now, first one is in case of low production and the material we are using is thin material. So, we will use stock strip stock, and it will be a single pass layout, that is cutting off one or more blanks at a time, at only one time. Now, second one case is in case of low production and thick material. When we are using thick material, again it is strip stock and a single or double pass layout, means cutting one blank at a time. The third case it is high production and thin material. Earlier two cases were of low production, now it is high production and thin material. So, we are using coiled stock and a single pass layout. Now, fourth case it is again high production and for thick material we are using strip stock and a single or double pass layout. Now, the die cost naturally will be higher for higher production and cutting more than once at a time, particularly when cutting extremely complicated blank sizes. Means when we are cutting blank shapes which are of complicated sizes, naturally the die cost will be higher in that case, and more is the accuracy, more will be the cost of the die. So, the designers they have to decide that while making the SOC layout as to what should be preferred, more operator time or more machine time. Next is the strip or process layout. Now, progression layout or strip layout is the first factor to be considered when it comes to progressive tool die design. When we are designing the tool, then the first factor which should be considered, it is the strip layout. So, it is the most important process in any tool design. Now, because this progressive stamping tool, it can give you nightmares, means it can bring you adverse effects if you make a single mistake in the strip layout. Because naturally, if the strip layout is not as per the design, then the material wastage which can be very high and which can result to the high cost of the material, and naturally losses will be there. On the figure 4, it shows the strip process layout design system. This is the flow chart of strip process layout design system. Now, for the design of strip process layout, the first step is that how to decide the feeding method, that how we are feeding the strip inside the press, which is according to the quantity of production, material properties, material thickness. So, all these factors have to be taken into consideration while feeding the strip into the press. So, this is the flow chart of the strip process layout design system. Now, the various factors which affect are, first one is the decision of web size, how much is the size of the web, that is distance between the blanks and the distance between the blank and the nearest edge. How much cutting allowance should be, side cutting allowance should be given, what should be the piloting method. Piloting method, this pilot, what it does is that it guides the tool towards the workpiece. Again, next factor is the discussion of the multi-row, whether we are feeding in single row or multi-row strip. Next is the translation rotation, that how we are strip is being, how is the, we can say that the burr rotation, it is clockwise or anti-clockwise. Then next is the advance or feed calculation. It is the main factor we have to consider in advance, that how much feed or should be given. Next is the graphic display, all the things should be displayed graphically before doing any work on the process. Next again design flow, what design of the strip should be considered. Strip layout design, it is the main factor which helps us in turn in the material utilization. Next is the part review of the part, what shape is of the part, again the calculation of feed. Then next is the calculation of utilization ratio, because this material utilization, it adversely affects the cost of the material. Again graphic display, and finally the discussion with the field. It is very important to discuss that what we have done in the various steps of making the process layout, it should be discussed so that we can get the further any improvements or not. Now, in this strip process layout, the first stage, this is the strip process layout, drawing of the strip process layout. The various stages are piercing stage, piloting, again piloting, then notching, then fifth stage is piloting, sixth one is idle, seventh is bending, eighth is piloting, ninth is again bending, 10th is idle, and 11th is again piloting stage. So, we will discuss in stages one by one. Now, the first stage it operates piercing, means cutting, and the second and third stage they work as piloting, means they just guide the tools, and the fourth stage it works as notching, means cutting the edges of the blank, removing the metal from the edges, that is called as notching. Now, again fifth stage it operates as piloting, What the pilot work does it takes the stability of strip, feed and location. Now, sixth stage, it is idle stage, means no working process is done in the fifth stage, and idle stage it has function of die assembly, space and die troubleshooting. Now, seventh stage, it again operates as angle type bending. Bending is done in the seventh stage as shown in the diagram. Now, during the seventh stage operating, the punch stroke has maximum region and the material wall comes down along the die block. Now, the eighth stage is again piloting, and the ninth stage is the bending stage. 10th stage it is again the idle stage, and 11th stage it is again the piloting, which is the final stage. Now, next comes the press working terminology. A simple cutting die used for punching and blanking operation is shown in the figure 6. This is the figure 6. This is a simple cutting die. So, you can see that it is in this diagram that there is a bed or of press. On this bed the bolster plate is being mounted, and on that bolster plate there is a die holder, which we can say that is the lower shoe. Above the lower shoe it is a die block. Then there is some packing material, then again there are two guide posts for guiding the ram. Then there is a stripper, then again there is a metal strip, punch plate, guide post bushes, punch holder for holding the punch, which is called as the upper shoe, backup plate, shank and ram or slide. So, we will discuss all these notations one by one. Now, first one is the bed. The main component of the press tools are described here. First one is the bed. Now, bed, it is the lower part of a press frame that serve as a table on which the bolster plate is being mounted. As I have already shown you, the bolster plate it is mounted on the bed. Now, second one is the bolster plate. Now, this is a thick plate secured to the press bed, which is used for locating and supporting the die assembly. Die assembling is being supported on the bolster plate. It is usually 50 to 125 mm thick. Now, third, it is the die set, complete die set. This unit it includes lower shoe, upper shoe, two or more guide posts and guide post bushings. Now, next is the die. Now, the die is defined as the female part of the complete tool for producing work in a press. Now, die block. Now, it is a block or a plate which contains a die cavity, means the shape of the die, it is included in the die cavity. Now, next comes the lower shoe. The lower shoe of a die set, it is generally mounted on the bolster plate of the press. I have already shown you the lower shoe is mounted on the bolster plate of the press, and the die block it is mounted on the lower shoe. Now, next comes the punch. Now, this is the male component, die is the female component and punch is the male component of the die assembly, which is directly or indirectly moved by and fastened to the press ram. Because during the stroke of the press, the ram moves up and down, and as the punch is attached to the ram, so punch also moves up and down during one stroke of the press. Now, upper shoe. Now, this is the upper part of the die set, which contains guide post bushings. Next comes the punch plate. The punch plate or punch retainer, it fits closely over the body of the punch and it holds it in the relative position. So, punch is being held by the punch plate. Now, backup plate or we can say pressure plate, it is so placed that the intensity of pressure it does not become excessive on the punch holder. So, what the function of backup plate is to distribute the pressure equally over the wide area, so that it does not become excess on the punch holder or it may break the punch. Just to avoid breaking of the punch or crushing of the punch, backup plate or pressure plate is being used. Next comes the stripper. Now, it is a plate which is used to strip the metal from a cutting punch or die, means to cut the metal from a punch or die. It also acts as a guide to the sheet. Next comes the knockout. Now, it is a mechanism which is connected to and operated by the press ram for freeing a workpiece from a die. For freeing a workpiece from a die, to get out the workpiece from a die, we use a knockout. Next comes the pitman. Now, pitman, it is the connecting rod which is used to transmit motion from the main drive shaft to the press slide or ram. Means with the help of pitman, a motion is being transferred from main drive shafting to the ram or press slide. Next comes the stroke. Now, the stroke of the press, it is the distance of a ram movement from its up position to its down position. Next comes the shut height. Now, it is the distance from top of the bed to the bottom of the slide with its stroke down and adjustment up. Now, next comes the type of dies. Now, the dies may be classified according to the type of operation we are performing on it. So, dies are classified as cutting dies and forming dies. Now, first one is the cutting dies. Now, these dies are used to cut the metal. The common cutting dies, they are the blanking dies, piercing dies and perforating dies. Now, second one is the forming dies. Now, these dies, they only change the appearance of the blank without removing any material or stock. Now, these dies, they include bending dies, drawing dies, squeezing dies. Now, on the basis of method of operations, the dies may be classified as simple dies, compound dies, progressive dies, combination dies, transfer dies and multiple dies. We will discuss these dies one by one. Now, first one is a simple die. Now, a simple die or a single action die means on single action means that on one stroke of the ram or on one movement of the ram, only one action, one operation is being done, that is either punching or bending or blanking. Only one operation is done at one movement of the ram. Now, these dies perform single operation. I have already told you, these dies perform single operation for each stroke of the press or slide. That operation, it may be cutting or forming. Now, figure 7, this shows a simple die. You can say that there is a booster plate and on booster plate there is a die set. Die is being fixed on the booster plate. On the top it is a ram, on to the ram is attached the punch and the punch moves up and down, and to die is held a strip plate, metal strip which is to be cut, and on the top of the strip it is a stripper for cutting the, for guiding the, we can say guiding the punch. Stripper is used for guiding the punch. So, during the downward movement of the punch, when the punch strikes the metal strip, the blank is being cut. You see that in the diagram, that blank falling through the die in booster plate, it is being cut during the downward motion of the punch. Next comes the compound die. Now, in these dies, two or more operations they be performed at one station. Means at one station, two or more operations are being performed. You can say that, for example, blanking and bending. In case of single die, simple die, only one operation was being performed, but in case of compound dies, two or more operations are being performed at one station. Now, such dies are being considered as cutting tools, since only cutting operations are carried out. Means blanking, piercing, these are all the cutting operations. Now, figure 8 shows a simple compound die in which a washer is made by one stroke of the press. Now, this is a simple compound die. You can see in the diagram that there is a die hole and a